We're on problem 27, and the question is, which equation best represents the graph above? So before even looking at the choices, let's see what we could figure out about this graph. So what's its y-intercept? So if we said that this is the equation of a line, we said y is equal to mx plus b, where m is the slope and and b is the y-intercept. It's late. I'm getting slightly muddled. So what's the y-intercept? Well, when x is equal to 0, y is equal to 0. So this is going to be equal to 0. The y-intercept is 0, right? When x is equal to 0, y is equal to 0. So the y-intercept is 0. So we know that this has a form y is equal to mx, where m is the slope. Let's figure out the slope. Slope is equal to change in y for a given change in x, or change in y over change in x. So when we increase x by 1, how much are we increase or decrease y by? Well, then y increases by 2, right? So we could say that equals y changes by 2, by plus 2, when x changes by plus 1. So we get the slope is equal to 2, so the equation of this line is y is equal to 2x, which is choice B. Choice B. Next problem. Which point lies on the line defined by 3x plus 6y is equal to 2? Well, the best thing to do is probably just substitute these numbers in for x and y and see which one works. So here x is 0, y is 2. So let's see, 3 times 0 plus 6 times 2 is equal to 0 plus 12. It doesn't equal 2, it equals 12. So it's not equal to, this one doesn't work. Right, I'm just taking 3 times x plus 6 times y and seeing what it equals. In this case, we have 3 times 0 plus 6 times y plus 6 times 6. Well, that's 0 plus 36. That doesn't equal 2. Can't be that choice. This one, we have 3, right? This 3 times 1 plus 6 times this y. 6 times minus 1/6. So let's see what it is. That's 3. That's equal to 3. And then 6 times 1/6 is 1, but we have a negative out there, so it's minus 1. So that is equal to 2. So that works. 3 times 1 plus 6 times negative 1/6 is equal to 2. So our answer is C. Problem 29. Let me see if I need to cut and paste this one in. All right. So I think it's a good idea. Let me see. Copy and paste it. Let me copy and paste the next several problems. We could just be streamlined about it. Okay, they all fit. Good enough. All right. What is the equation of the line that has slope of 4 and passes through the point 3, minus 10? So if the slope is 4, we know that the line, so if just rewrite it in slope y-intercept form again, mx plus b, they're telling us that the slope is 4, right? So we know the equation of the line is y is equal to 4x plus the y-intercept. And then we could figure out the y-intercept by substituting in this point that they say it goes through. So it goes through the point 3, negative 10. So y is equal to minus 10. Y is equal to minus 10 when x is equal to 3. So 4 times x is equal to 3, plus b. So what is that? It's minus 10 is equal to 12 plus b. We could subtract 12 from both sides of this equation, and we get minus 22, right? Minus 10 minus 12 is minus 22, is equal to, this 12 obviously goes away, is equal to b. So the equation of our line is y is equal to 4x plus b, which we just figured out is minus 22. 4x minus 22. That's choice A. Problem 30. The data in the table show the cost of renting a bicycle by the hour, including a deposit. All right. If hours h were graphed on the horizontal axis, let me see if I can draw that. So that is on the horizontal axis, I have hours h. So this is h, and cost were graphed on the vertical axis. Let me draw the vertical axis. So cost is on the vertical axis. What would be the equation of the line that fits the data? Okay, so they just want to know cost as a function of hours. So let's see. We could, it's a linear relationship. We could treat this just like any other line. So if we write it as y equals mx plus b, I didn't even have to do this. So y is equal to mx plus b. So m, or the slope, is equal to change in y over, or let me write it differently, because we want it in terms of, so we could write c is equal to the slope times the hours plus b, right? Instead of x, we have hours, and instead of y, we have the cost, right? So what's the slope? Slope is equal to change in the dependent variable, change in cost, divided by change in the independent variable, divided by change in hours. So let's see. If I say, when our hours increased by 3, how much did our change in C go by? When we go from 2 to 5, so if we say 5 minus 2, that's how much we changed in hours, right? That's delta H. Then how much did we change in cost? Well, it's 30 minus 15. So it equals 15 over 3, which is equal to 5. So we figured out the slope. Slope is equal to 5. Now we just have to figure out the y-intercept. So this equation, we could rewrite it as cost is equal to the slope, which is 5 times the hours plus whatever our y-intercept is. And now we just have to substitute one of the points in to solve for b, just like we did in the previous video. So let's substitute the point when h is equal to 2, c is equal to 15. So the point 2 comma 15. So when h is equal to 2, c is equal to 15. c is equal to 15 when h is equal to 2. And now we can just solve for b. So you get 15 is equal to 10 plus b. Subtract 10 from both sides. You get b is equal to what? 5. So the equation of this line is cost is equal to 5 times h, plus our y-intercept, or plus our c-intercept, we could say. So plus 5. 5h plus 5. And that is choice C. And if you try it out with these points, it should all work. Okay, next problem. Let me see. I think this cutting and pasting works out well. I think I have time for at least 2 more. Okay, let me clear this. Clear this one right here. And let me paste it in. Okay, it says, some ordered pairs for a linear function of x are given in the table below. Okay, it's kind of like the last one. Which of the following equations was used to generate the table above? Well, we could do the same thing we did the last time. We could say, okay, this is going to have some relation, y is equal to mx plus b. It's going to be a line, and this is the slope y-intercept form. And they tell us it's a linear function, so that's why we can immediately say, oh, it's going to be a line. There's no x squared or anything like that. So a good place to start is just with the slope. So slope is equal to change in y over change in x. So let's see, when x goes from 1 to 3, what does y go for? It goes from 1 to 7, right? So change in x is equal to 3 minus 1, or just 2, right? And what's change in y? 7 minus 1. So that is equal to 6 over, oh no, sorry, change in x was 3 minus 1. Sorry about that. 3 minus 1, so it's 6 over 2. All right, when x changes by 2, right, that's this 2, change in x, y changes by 6, change in y. So the slope is 3. So the equation of our line is going to be y is equal to 3x plus some y-intercept. And now we could substitute some points in. Let's substitute this one. This 1, 1 seems easy. So y is equal to 1 when x is equal to 1. All right. So we get 1 is equal to 3 plus b. Subtract 3 from both sides of this equation, and we get what? 1 minus 3 is minus 2, is equal to, obviously this disappears, 3 minus 3. So b is equal to minus 2. So the equation of our line, we have a slope of 3 and a y-intercept of minus 2. The equation is going to be y is equal to 3x plus b. Well, b is minus 2, so minus 2. And that is choice C. Choice C. 32. The equation of line L is 6x plus 5y equals 3, and the equation of line Q is 5x minus 6y is equal to 0. Which of the statements about the two lines are true? Okay, let's see. They have the same y-intercept. They're parallel. They have the same x-intercept. Lines L and Q are perpendicular. So, well, I'll tell you how you can identify perpendicular lines. They have the negative inverse of each other's slope. But I don't know if that's going to come into play yet. I always find it easier to look at these lines in kind of the slope y-intercept form. So let's do that. So line L can be 6x plus 5y is equal to 3. So if we were to subtract 6x from both sides, you get 5y is equal to minus 6x plus 3. And then you divide both sides by 5, and you get y is equal to minus 6/5 x plus 3/5. So this is line L right here. I'll do line Q in a different color. So Q is 5x minus 6y is equal to 0. Let's subtract 5x from both sides. You get minus 6y is equal to minus 5x. If you divide both sides by negative 6, you get y is equal to minus 5 divided by negative 6. It's 5/6 x. So look at it. Well, it actually looks like D comes into play, because the slope of this one is minus 6/5. That's the slope of line L. The slope of line Q is the inverse of that made negative. And that's at this point, it's a good thing to memorize. I haven't proven it to you yet. But when you want if you want a line that has a slope perpendicular to this one, or a line that is perpendicular to this one, will have a negative inverse slope. So the inverse of this is minus 5/6, and the negative inverse is plus 5/6. So this is the negative inverse of that. So these lines are actually perpendicular. So that is D. See you in the next video.